Hello. So I'm making this video to explain question 4 on chapter 6. We have two alternatives, A, B, C, and the second alternative, X, Y, Z. So if MARR is 7%, determine the best alternative from the following table using the rate of return analysis. So we have initial cost for both of these alternatives. We have benefit per year. We have a salvage value. We have an N for uh, both of them. One is 4 years and one 6 years. So what we need to do, we have to follow the steps. And if you see these steps these steps are included in the textbook. If you go to the chapter, you will see these steps. But just one more time, what we're gonna do, we're gonna follow these steps. Step number 1, we have to sort the alternatives based on the initial first cost, lower to higher. So if we rank them, we say XYZ first, and then that would be ABC. Step number 2, you need to build the cash flow for these alternatives based on an equal lifetime using the least common multiplier. And if you look into the least common multiplier between 4 and 6, that would be 12 years. Subtract the cash flows from both of them from the higher alternative, or the higher alternative minus the lower initial cost alternative. Then use the IRR Excel function on the difference between the cash flows to find the rate of return. In the next step, number 5, compare the value with the minimum acceptable rate of return. If it's higher than the minimum acceptable rate of return, then select the alternative with a higher initial cost. If not, select something with if not, select the other alternative, which is the lower initial cost. And the last step is to make the decision and make your conclusion. So build your cash flow from year 0 all the way to year 12. Initial cost for ABC would be 22,000, and we're gonna get 16,000 every year. This is a benefit all the way to year 12. And since this is a 4-year alternative, we have to have 3 cycles of ABC. So on year 4, we have to buy a new alternative. We're gonna get also the salvage value. Don't forget about the salvage value. We're gonna get the salvage value of 15,500 as included here in this table right here. And you're still gonna get the benefits. So same thing for year 8. You're gonna buy a new alternative and receive the salvage value from the old alternative. Last year, which is year 12, you're not gonna replace the alternative. You're gonna get the benefit and the salvage value. So that would give you the 31,500 as a net cash flow for year 12. Same thing we're gonna do for X, Y, and Z. Build the cash flow from 0 to 12. On year 0, we have 18,000. Year 6, which is the second cycle, we have to buy a new alternative, and we need to get the salvage value. On the last year, year 12, you will get only the salvage value. And in this case, what would you do? You subtract the ABC minus the XYZ as I did here. And for all the cash flows, you build the cash flows. And one thing that you need to see positive and negative. Mostly, you want to see mostly positive cash flows. Now, if you see all negative or mostly negative, that means you're not going to get any answer. You're not going to get the number. So in this question, we have mostly positive cash flow, which is good. What you need to do, you use the IRR to find the IRR, the rate of return for the subtraction. And this is just the incremental analysis. This number, the one that we got here, 71%, doesn't mean anything. It doesn't mean any thing is there's no way to make a conclusion based on the 71. It's just a criteria that we use in the incremental analysis to compare it with a minimum attractive rate of return or minimum acceptable rate of return. So the MARR is 7%. We look into the IRR out of the incremental analysis, and we found that this is higher than the MARR. Therefore, we should select the one alternative with the higher initial cost, and therefore we have to select the ABC alternative. Thank you very much, guys, and please let me know if you have any question on this particular problem. I hope this video helps, or otherwise, if you have any questions, just send me an email. Thank you.